Stretch a steel spring and it snaps right back. Stretch it too far and it stays bent forever. Where is the line between those two? That line is governed by one of the most important laws in all of engineering, Hooke's law. Welcome back to Solid Mechanics. In this detailed lecture, we will master Hooke's law, the stress-strain curve, and the elastic constants e.g. K and Poisson's ratio that every later chapter depends on. Let's draw it out. Within the elastic limit, stress is directly proportional to strain. Sigma is proportional to epsilon. Remove the proportional sign and you get sigma equals E times epsilon. That constant E is the modulus of elasticity or Young's modulus. Robert Hooke stated it back in 1678. But notice those three words, within the elastic limit, that is the catch. Hooke's law is a straight line and it only holds while the material behaves elastically. Pull a mild steel bar and plot stress against strain. First, a straight line from O up to A, stress proportional to strain. So A is the proportional limit and Hooke's law is valid only up to here. Just beyond at B is the elastic limit, the last point that still springs back with no permanent set. Push further and the material yields at the upper and lower yield points, stretching a lot at almost constant stress. The curve climbs to D, the ultimate stress, the maximum it can take. Then it necks and breaks at E, the fracture point. Remember the order. Proportional limit, elastic limit, yield, ultimate fracture. The slope of that straight line is Young's modulus. E equals direct stress over linear strain. Sigma over epsilon. It measures stiffness. The higher the E, the harder to stretch. Its units are Newton per square millimeter or gigapascals. For steel, E is about 200 gigapascals, 2 times 10 to the 5th Newton per square millimeter. Aluminium is about 70 and concrete around 25 to 30. Steel is stiff and that big number is Y. Hooke's law is not just for stretching. Apply a shear stress and the element distorts by a shear strain. Within the elastic limit, tau equals G times gamma. G is the modulus of rigidity, also called the shear modulus. It is the stiffness against twisting and sliding. For steel, G is about 80 gigapascals, roughly 40% of E. Now squeeze a body equally from all sides like an object deep underwater. It shrinks in volume. The volumetric stress over the volumetric strain is the bulk modulus K sigma equals K times epsilon V, where epsilon V is the change in volume over original volume. For steel, it is about 160 gigapascals, so E, G and K are just Hooke's law for stretching, shearing and squeezing. When you stretch a bar longer, it also gets thinner. That sideways strain divided by the stretching strain is Poisson's ratio nu for steel. It is about 0.3. It always lies between 0 and 0.5. And at exactly 0.5, the material is incompressible. Its volume does not change at all like rubber. Here is the beautiful part. E, G, K and nu are not four separate numbers. They are locked together by two golden relations. E equals 2G into 1 plus nu and E equals 3K into 1 minus 2 nu. What this means is huge. For an isotropic material, there are only two independent elastic constants. Give an examiner any two of them and you can calculate all the rest. One of the most asked facts in the entire subject. Let's use it. For steel, take E equals 200 gigapascals and nu equals 0.3. Find G and K. G equals E over 2 into 1 plus nu, that is 200 over 2.6, about 77 gigapascals, and K equals E over 3 into 1 minus 2 nu, that is 200 over 3 times 0.4, which is 1.2. So K is about 167 gigapascals. Two constants in, two more out, clean. But always respect the limits. Hooke's law holds only up to the proportional limit. Beyond it, the curve bends and the material deforms permanently, and some materials like rubber or brittle cast iron do not follow a neat straight line at all. So Hooke's law is a powerful idealization, true for elastic materials within their elastic range and nowhere else. In one breath, Hooke's law, within the elastic limit, sigma equals E epsilon. The stress-strain curve runs proportional limit, elastic limit, yield, ultimate fracture. Three moduli, E for stretching, G for shearing, K for squeezing. Poisson's ratio nu links them with E equals 2G into 1 plus nu equals 3K into 1 minus 2 nu, and only two elastic constants are independent. And that is Hooke's law and the elastic constants in detail. This subject is a free package. The lecture, an MCQ practice paper, and a full solution video. Every day a brand new subject. Tomorrow, get ready for surveying and geomatics. All the free notes and PDFs are on our Telegram. Learn Civil Easy. Subscribe, tap the bell, and I will see you in the next class. Take care.